Okay, this MCT4C, day 12, we're back. Part 2, graphing sinusoidal functions. Graphing calculator. Now, this is really just for a check, because we're pretty confident of this. This is review for us anyway, but, you know, we're technology type folks, so let's check them out. This is the first one, and notice I've got my window settings are kind of the typical ones for trig functions, and I got sine in there from yesterday, obviously, and x, what was the first one? It was plus 30 and x minus 60. No, hang on, I've goofed that up. This is plus 60 here. And this is minus. Now these are going to graph pretty quick and they'll be hard to distinguish. So notice how I scrolled back behind the y2. You can actually change it to a thick line or a dotted line, so we can tell the difference between them a little bit, I suppose, if we want to. There's other ones there. There's a dotted line. And now I'm going to press graph. There was my original. There's the one that's been moved right 30 and left 60. 2 ticks from the original. That doesn't look very dotted, but wow, it looks the same. Okay. Now notice here though, if we go and do the second example, cos x, and we got cos x, what was it, plus 1 and minus 2, right? Plus 1, delete, minus cos plus minus 2, cos x minus 2. There's the original one, you know, high, middle, low, middle, high, and so on. And then there's some, it gets cut off, right? Because this is 1, the way we set up the scale, that every tick, we set it up, the original, every tick was worth 0.5 and it only went up to 1.5. So we wanted to change our scale so we can see the whole thing. I don't know how far down we want to go, maybe 3, I think is what we did in our notes, and up to 3. And maybe every tick along the y-axis would be worth 1. Then graph it. See, there's the original. There's the one that's been moved up 1, and I can sort of see where the axis would be right there. The new axis would be down 2 here. And there we go. Checked with graphing calculator. Check. Conclusions. So this graph, and notice that the cosine is similar, but we're just using sine because it's the first one we did. This graph is just the original graph moved, well, since it's minus d, right d units, and that was called a phase shift. And moved up c, right? Up c. And now this one actually has a whole bunch of names. One of them is boring, but that's okay. Vertical displacement. Displacement just means like a change in position, right? Vertical means up and down, so it's kind of just a fancy math way of saying up and down. What's neat though is this value often has different names. I in the video was calling it the axis. So I mean, we think of that being the x-axis, but when we moved it up, then it's kind of like it's going back and forth over a new axis. This is the new axis, right? We also call it the resting point, and we'll see why that makes a sense to call it the resting point later when we do applications. Or it's also called the average. Average is a term you're used to, and we'll see how that fits in with trig soon. Onwards. Determine the phase shift and vertical shift, then graph for 2 complete cycles. Vertical shift, I called it a displacement. Vertical shift, that's fine. Phase shift is the left and right one, so I can see there. I'm going left. Is it left? No, I've goofed that up, haven't I? It's opposite, you'd think. You think minus would be left, but it ain't, is it? It's right. It's the opposite. And this is up 2. Oops, up 2. Now notice that we don't have the scale written on here. And it's for 2 cycles, so that means we have to not go up to 360, but further than that. And hopefully I can fit this all on my graph paper, and you can fit it on your graph paper, I hope. Notice that this graph is going to be moved up 2, so I'm going to put my axis down here a little bit and set up my scale. I'm not going to put all the numbers on it, but I know my important points are every 90 degrees, every 3 ticks. 3 ticks, 3 ticks. So this is 90, 180, then this is 360. That'll be the end of the first cycle. Another 180 is a bunch more, and so on. Here, I know I'm going to go up as far as 2, so how far am I going to have to go? Well, the normal graph goes up to 1 plus 2. I'm going to have to go up to 3, so maybe a scale like that would be okay. If that's 1, that's 2, that's 3. Once you get used to these, it's not going to be necessary for you to graph the original one. I am, because we're just sort of getting going here. The original graph, cos x starts at 1. And then repeats the pattern. This is the original graph. Oops, and it's for 2 cycles, so I've got to keep going. Fun. This must be 720, 2 cycles, right? 720 degrees. And this is the original graph. Notice that I could do it right 30 and then move that graph up 2, but I'm going to see if I can skip right to the final one, because where's the original, like this starting point is going to be moved right 30 or 1 tick, right 30 and up 2. Up 2. Make sure you go up 2 units, not 2 squares. There's the starting point. And if I move the axis up 2, then all I have to do is repeat the pattern, knowing that I've got the starting spot. That's the starting spot. It's been moved right 30 degrees and up 2, and then I know the important points are every 3 ticks, every 90 degrees. 3 ticks, important point. 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 And notice the pattern just continues. High, medium, low, medium, high, medium, low. And it's not 1s and 0s and negative 1s, because it's been moved, hasn't it? And if I wanted to state the characteristics, I could do that. If I wanted to check it on a graphing calculator, by all means, you should be able to do that. See, what the only characteristic that's changed is the range, and we could state that if we wanted to, but I'm not going to bother because you're good at it. Next. For each description, give an appropriate equation. A sine graph with a phase shift of right 26 and a vertical axis of 3.2 units. So it's a sine graph. So essentially it's there's the general way. And we know that this has been moved right D and up C. So this gives me this right 26, that's D, and vertical axis of that's C. And you see, when these numbers aren't nice numbers, that's when we're starting to talk about applications, maybe, when it's, these strange numbers. Write a sine function for the given graph. Well, here, I think what we got to do is find the axis, Because if it's a sine function, where's the start? We're looking for the starting spot, right? Well, there's the axis halfway between the bumps. It looks like the axis is -2. There's the axis -2. And so that's the C value. And then where's the starting spot? Starting spot's right there. So that's been moved right 30. And -2. Done. Notice that when I say, could have I said it was right that much, like 390 degrees? Yeah, that would have been the same thing, right? Unfortunately, there are an infinite number of answers that make sense because, this keeps on going forever. It can be moved left and right as many times as I want to. So there are more than one answer, or there is more than one answer, rather. My English is correct. Even this, now, some people could have saw this as a cosine function, right? They said, well, I didn't see that that was the starting spot. To me, the starting spot was right there, because then it's a cosine function. Well, notice the axis is still the same. C is still -2. But what's the phase shift? Well, I've moved right that many spots to get to that phase shift. That is how much? 30, 60, 90, 120. Right 120. Notice that if we'd moved left, this would be a positive. And I think that's it. Notice that one way to check these is to graph that and see if it matches that graph. On like a graphing calculator, I mean. Okay? Done.